Hello, so today we are going to do this Leetcode 30-day challenge, day number 23. And the problem is bitwise and of numbers range. So the problem says given a range m to n where m is between 0 and this number and n also is between 0 and this number, but m is smaller or equal to n, and this is a range, right? So basically it's a range that is included in this bigger range 0 and this big number. And we want to return the bitwise AND of all numbers in this range, right? So we want to AND all numbers in the range m and n. Well, definitely a brute force solution would pretty much work. So this is, I think, is just if we take the terminal here for a little bit and look at float. So in Python, so if I say system.maxint import okay, that's weird, but maybe that's a Python 3. But yeah, that's the number, so it's the max number possible. So if we take a range from, so we could just do this, right? Start from m all the way until n plus 1. And we start with, let's say m, right? And then we do m plus 1 here. And we could just keep doing like this. It's end actually, so it's not XOR, so it's end like this. We return S. This may give us time limit exceeded, right? But let's try it on the biggest, on the smallest one and the biggest one, biggest range. So the other range would be 0 in this. Okay, so we definitely get time limit exceeded. Yep. So how can we? Can we have anything like, if we know that I plus 1 and then we have I plus 2 and then I plus 3, this is how it's going to work, right? And I would start from m and we'll keep going until n, right? So what we are interested in is there a property for this? So let's say we take the bits for 7 and the bits for 8, right? So this is I and this is I plus 1, right? And so this is I equal to 7, I plus 1 equal to 8. Okay, so if we look at this, we erased everything and then we just, so if you end these two, if we end I and I plus 1 here, we will get 0, and then 0 and 1, That's, so if we do here 0 and 1, that's 0, and that's going to be zeros all the way, right? So that's 0 actually. Yep. So this tells us anything we need. This won't be the case every time. It's only the case for these numbers that have all ones here, right? Because 6 is, if we look at 6 and 7, which are like this, then if we do AND them, then we will get 0, right? B, 1, 1, 0. So we'll end up with 6. Okay, so one thing I can notice here though from just looking at these is 8 is even number, right? So it has 0 at the end, and 6 is an even number. So any even number, so we know that at least any even number, so any even number will end with a 0, right? And since it will end with 0, we wanna get the final result, right? So the final result, which means that if there is an even number in the range, that means that it will end with 0, like the result will end with 0. Now, I think we can extend that, right? We could extend that here, and the numbers that will end with this 0 will also make it end with 0 here, right? And so, can we do this recursively? In a way. So, so how would we do that recursively? So for a number like this, doing it recursively means just cutting this and checking if it's even, right? Yes, yep. So what that would mean, cutting the last 0 means the last 0 just shift, right? So let's say this is x, we will just need to do x1, right? So let's say if I say x is equal to 8, x is equal to 8, what is the binary of x? That's this. What is the binary of x shifted by 1? You could see I have it like this, right? So what this would mean is I could just work with m and n and check if there is an even number. How do I check this? Well, if the difference between n and m is bigger than 0, right? So there is at least one difference, which means maybe it's 1 and 2. There is a difference of 1 between them. So one of them has to, when you have two numbers that are one after the other, one of them has to be even, right? Either the first one is even or the last one is even, right? The only case where it won't be the case is if we have something like maybe 1, 1, right? This is 1 minus 1, which is 0, right? So for this one, it won't work. And so what I can do here is basically, while m is not equal to n, I can just keep shift both m and n. Now, the main question would be, what should I return here at the end? Well, I could just do this at the end, right? Well, that won't work because that would be 2 and 2. So 2 and 2 is 2, right? So I could just return one of them, m and n, because they will be equal at that point. I will get the final number. So I think, yeah, I think what we can do here is just, while m is different than n, can do something like this, and then something like this, and then I'm not sure if this is enough. Return M. Seems like there is no expected answer or something. Okay, so that one worked. Okay, the first one expecting 4, I'm getting I'm getting 1. Yeah, I don't think this is enough, right? I think that I need to do something here and get the final result there. So actually what we need to do, I think, is we need to keep track of the by how much we moved, right? Because those are represent even numbers, represent last zeros, right? Which means in the last solution, we need to shift by that number, right? So that we can get zeros there. So let's just keep track of that. Let's call it offset here. And then here, let's say offset equal to, we increment it by 1, right? And then here we need to move so that these become zeros. And that's pretty much it, I think. Okay, let's try with 6, 7, 8, 8, 9, 12. Okay, that does look good. So yeah, so the main idea is even numbers end with zeros. A range of mn, if they are not equal, there is an even number. If there is a number, since we are ending the numbers, then the value at the last position would be 0, and we keep dividing so that we can determine if there was a 0 here, because if it is, then this bit is also 0, and now we know like these last values in the last result are zeros, and so we just move by how many we did find. So let's see if this passes. Yeah, it does. Cool.